My name is Eric Chou. I'm here to talk to you about network data analysis with Elastic Stack. So first of all, let me introduce myself a little bit. I've been working in the networking industry for the last 20 years and worked in the service provider, enterprise vertical, and in roles such as the operator, sales, research, and many, many others. I'm also the author of Mastering Python Networking. Currently, this is in the third edition, so thank you if you have seen the book. If not, that's okay. I'm also ex Amazonian, ex Microsofty. That's where my network automation journey kind of began. So, we were working in a large scale data center environment, and automation was one way for us to solve the problems at hand. Currently, I'm working as the at the A10 network security research team. So my current role is kind of a bridge between operations developers as well as researchers. All the code and examples I'm about to give in this talk are on the GitHub repo. So, if I find something new or, something needs to be updated, I will go ahead and update that repo. So feel free to check that out later on if you're watching this asynchronously. Also, I'm going to include a pre-recorded demonstration in that linked from that code repo as well. So first of all, let's talk a little bit about the Elastic, the company versus Elastic, the project. I find this as one point of confusion for some people. So Elastic Stack projects are open source, free as in freedom projects that are being worked on by the community as well as Elastic, the company. The Elastic company is actually started by the people who started the Elastic project, but the product themselves are not commercial, and the company actually offers support, make money by offering support, consulting, training, and so on. But Elastic Project is actually free as in freedom, free for people to use, to contribute, and open source. So in this talk, we're actually going to talk about when we say Elastic, Elastic Stack, or anytime we're referring to Elastic, we're actually talking about the project and not the company themselves. So first of all, what is the Elastic Stack? So Elastic Stack is actually a group of open source projects that are developed and tested together. As you can see from the screen, there are actually quite a few projects under the Elastic Stack. This is kind of unique in the way that it's a turnkey solution. You could just grab all the project at once, and you have a high confidence that they'll work together because they're developed and worked on together and tested together. But at the same time, you can actually pick and choose. In each of the individual projects, you could pick and choose if you don't like a certain component, if a certain component that doesn't work well for you. For example, if for the visualization, if I don't like Kibana, I could easily take that out and switch it out with Grafana or other visualization tools. But one exception is that the center of this Elastic Stack universe is Elasticsearch. So Elasticsearch is a distributed RESTful search and analytic engine that's kind of at the center of every single component, at the center of these stacks. So you probably don't want to swap that out, but all the other components, we could actually work around it or change or whatnot. And also there's three other projects that are kind of considered the cornerstone for the Elastic Stack. So if we think about the middle layer as Elasticsearch, that's where you store your data. We have to have some way of ingesting the data, and that data input is either through Logstash or Beats. So Logstash is actually a server-side data processing pipeline. It takes different inputs, enrich them, and transfer them before they output it into Elasticsearch. Beats does the same thing, but they're a client-side small daemon-based software that are specialized data shippers. So for example, if I have a Nginx web server, I will find the specific beat that's made for Nginx monitoring, install it on my server, and that would just enter those data into Elasticsearch. So these are two different ways of ingesting data into Elastic. One is on server side, one is runs on the client. And another project that is commonly referred to as the cornerstone in the stack is Kibana. So Kibana is the visualize engine that takes all these data and visualize them in a way into pie charts, bar graphs, or whatnot, or just simply entries, right? They also offer another function, which is the GUI interface. So they provide these GUI interface to manage Elasticsearch indices if you wanted them to. Of course, you could always manage Elasticsearch via API, but sometimes it's just easier to do it via Kibana. So this is a good way to visualize the stack, how the data flows through the stack. So at the very bottom, you have these data shippers. One's on the server side, Logstash, one's on the client side. And once they aggregate the data into Elasticsearch, and Elasticsearch usually is run as a cluster. They have the primary node, the data nodes, and just to provide a distributed storage as well as fault tolerance. So once you get into that Elasticsearch, into this Elasticsearch cluster, that it gets bubble up, data gets stored, it gets bubble up to visualize via Kibana. And all the other projects are kind of built on top of either Elasticsearch or Kibana. For example, the SIEMs product, the security monitoring product, is built into the Kibana dashboard to kind of analyze for security breaches, threat analysis, and so on. And we could also build in application infrastructure monitoring for another project, and that's built on top of Kibana. Of course, Elasticsearch could have its own project as well, such as providing product search for a web portal, or for case analysis if you use it in the case tracking system or whatnot. So these four are the cornerstones, and that's how the data flows upwards. And all the other projects are kind of bolted on into these two projects. So who uses Elasticsearch? A lot of people, because if we think about it, a lot of the problems we face are actually questions that we want answers to based on data. For example, I could be asking how many people visited my site yesterday, and who are those people, which IP addresses they're from, which location they're from, what age group they're in, and so on and so forth. So that is a search question, right? So Elasticsearch could answer those questions. Or as a network engineer, I may be asking, what percentage of TCP data is in my network, and what percentage of UDP and location, and so on. So that is another search query. And the search query could actually get pretty detailed. For example, I could be asking, have I seen any invalid logon attempts on the second Sunday of last month between 3 to 4 p.m., right? That is a very detailed question that, as long as you construct your search query correctly, that is another question that we can answer from data. So a lot of people use Elasticsearch for different things because they're able to aggregate those data into the same location and find the answers to the questions. And why do we want to use Elasticsearch for network data analysis? I think by far the most important reason is that networking is really kind of like the messy middle. So if we think about the OSI layer, you have the presentation, you have these different applications, web server, mail, streaming services, all of these different services that are aggregating into this middle layer like an hourglass, right? That's the networking layer. Everybody comes down to a networking layer. And if you think about the OSI layer one or two, you have different transports. You have cell phones, 5Gs, 4Gs and 5Gs. And you have these broadbands, you have these fiber optics, you have the undersea fiber, you have all these satellite links, and all of them actually goes up into the middle. So networking is actually a great place to grab data in and to do your analyze and find answers for your questions on. However, the problem really is that these networking data could come into so many different places. It could be from logs, it could be from net flows, it could be from SNMPs, and many others. So we need a place for to normalize these data into a single format so that we could analyze them. For example, without Elasticsearch, if I have individual tools for say NetFlow and SNMP, I may be looking at the NetFlow analysis and to find my top talkers. And now I find my pair of top talkers. If I need to know more information about these hosts, I actually have to go use SNMP to actually query these hosts to know the OS version that they're running on, or the hot interfaces and so on. So it's very valuable. It's a game changer and pretty valuable for us to actually be able to aggregate different sources of data into a single location so we could analyze them. So what can we do for these network data? So what are the use cases? Of course, the first one is we could aggregate these data, normalize these sources, and then just search. We could find insights into questions that we have. And the second is we could do monitoring. We could observe how our data is doing. If we have time series of data, we could actually scope down to say, what is going on in the last month, what is going on last week, last day. So we can actually just normalize these data and observe over a period of time what happens to our network and take actions accordingly potentially. And also we could find security. This is kind of near dear to our heart. We do security analysis, we do threat detection and responses. This also includes endpoint security. If you think about having a security analysis or endpoint beats like software on the endpoints, and does something that's on the edge and aggregate it into a central location, that is also a good use case as well. So this is an example of how we take publicly available data such as Twitter and we aggregate them for a use. So the problem set is that Twitter is by default very noisy. There's just no way that we could mine that data manually. And also by default, I think Twitter only allows us to search back into 30 days. So what we could do is we could have a streaming service from Twitter, normalize them into like a JSON document. And if you notice that single document actually has a lot of metadata. It has location, it has how many retweets it has, and how many people liked it, and so on. So this is a very rich data set, and that is just one document. And then we could actually put them into Elastic, aggregate them into a time series of data, and then we could store them for longer than 30 days if we needed to. So this is a great use case for how we can actually transfer something that's publicly available, but enhance it and able to combine them with something else and provide useful information for us. So this is a example of us using different components for visualization. So as we've mentioned before, we actually have these different sources of data that we have aggregated it in. And for visualization, instead of using Kibana, we actually just construct a whole different website, a whole different portal that's based on JavaScript, but on the back end, it still uses the same Elasticsearch data. So this is just an example of how we could just swap out components of it. So if we look at the workflow, now that we know, we do the data ingestion, we do the data storage, and now we have some kind of output, some kind of visualization. How exactly what does it look like, right? So so the data ingestion here is just a workflow example. So for example, if we want to aggregate both the log data as well as the netflow data, you can see on the left side it's a two-step process. On the left side is we have the device configuration that exporting to the same host on my syslog as well as the netflow data. And on the right-hand side, I have a Logstash that has a configuration that's being shown on top of there that has listened on 3 different UDP ports. And I'm enriching and transforming that data. I'm adding a value of type so that I know whether the log is from iOS or from NXOS. So essentially, I have 2 sources of data that could differentiate. And then I have one single port that I'm listening for all netflow data. So regardless of whether it's the iOS device or NXOS device, they're all coming in. And I'm able to just aggregate those data in. And if you look at the output section actually creates 2 different indexes based on syslog or netflow. And it also has a wildcard at the end. So it automatically, if you look at those percentage signs, it automatically rolls over, creates a new index when the days rolls over. So every 24 hours is pretty convenient. Every 24 hours, it creates a new index. And we could choose our storage policy, whether how long we want to store it, how long we want to keep it fresh, and what's the data retention policy for our organization. So once we get those data in, now we have the data storage and we have the data aggregation. Here are just examples of how we could use Kibana to manage the indices. So we actually have a wildcard that we could use to recognize these indices. And also another example is how we could use Kibana, the dev tools, to actually test the APIs of our Elasticsearch. So those are pretty pretty powerful tools that Kibana provides. And of course, once we have those data in, once we have them recognized in Kibana, we could start doing visualization. So in this case, I'm showing a pie graph as well as a bar graph. And we could do more. We could actually do machine learning, because nowadays every single presentation have to mention machine learning or AI. Otherwise, it's not. It doesn't have any street creds. so obviously we could do machine learning and AI. And on the chart here it shows a unsupervised learning for just normal predictions, and those two dots that are falling out of the projection. So potentially you would just get alerts or something like that. So of course, let's do a quick demo. And so what you could see right here is the GitHub repo, like I've mentioned before. So this is where I keep some of the useful links for Elasticsearch and product documentation. And here's a pre-recorded video that I recorded for a for this example of what we went over, how to aggregate syslog as well as netflow information. These are the configuration snippets. Due to time, I'm just going to quickly go over, string through the video. And if you're curious, or if you have time when you watch this recording asynchronously, go ahead and watch it slowed down. But what I'm going to do is I'm going to quickly scroll through them. So I have this 3-node network that consists of NXOS as well as iOS. And finding out the IP, I go into the IP. I'm showing you that I am transporting the UDP to port 5144. And now I'm doing netflow exports onto the same host on a different port. Okay, cool. So now this is the iOS configuration, I believe. Oh, I'm sorry, the swap that. So it was the iOS, now it's the NXOS. And now that the flow is there, I'm going to show that the Elasticsearch and Kibana status. I've provided the links for installation. So if you're using a different host, feel free to look at different sections. But in this case, these are the Ubuntu host, and I'm just showing how to tell that your Elasticsearch and Kibana are running. And this testing is the local host to the 9200 by default. That is where they're listening to. That they this is generally what you would do, or once you finish it. This is the API. This is a RESTful API, no authentication, and then you see the body back. And what you want to do is actually matching the Kibana. The Kibana version with the Elastic version. So in this case, I'm running 6.5.4. It's a little bit outdated. But what you want to do is you don't want to run like a 7-point something Kibana with a 6-point something Elasticsearch. So match those two versions. And now that I'm showing the Logstash configuration for the syslog as well as the netflow, and the output, one output is to the local host, and the other output is actually to standard out console, so that we could observe those entries later on. And of course, as I mentioned before, we could take wildcards for the indices creation. So every 24 hours, it actually rolls over, which is really nice automatically. And if we just move on to more outputs, so that running the Logstash, and if you remember, one of the outputs is on a console. So now we're able to observe the netflow data that comes in, and this is just JSON. With key value entries. That it's pretty nice that when you first start it, I would always recommend to punt it to the console. Once you're happy with it, go stop the process, comment out the console, and then just save yourself some space. But in the beginning, always able to look at the console. That's pretty nice. So now I'm just demonstrating that there are syslog and netflow entries that are coming in. And then now that I have those indices, by default, Elasticsearch allows you to create those indices as soon as they receive them. However, Kibana at this point doesn't understand or doesn't know that the indices are available within Elasticsearch. So now what we're going to do is we're going to show the management function for Kibana, where I could just pick and choose, create an index pattern where you choose a wildcard for Cisco netflow, and then choose the timestamp field as my my field to indicate time. Because remember, these are time series of data, so it's important to keep a field that's time, so I would know what range that this data entries actually belong in. So once I created that, you could see that I already know the previous data that was within Elasticsearch. So I could go to the Discover panel and I could quickly look at those entries as well as put in a filter. So now I put in the filter for NetFlow version. So now I'm only showing the NetFlow version 9 entries. And you can, this is just to show that you could easily toggle between show or non-show, apply or not apply the version. So of course, once you have a filter, such as in this case, I'm using that filter to just log into 172.16.1.79 host. What's nice is also, you can actually come into this in this more information page where you could actually find out the exact request. So the Kibana backend is using the same API call for the front end. I'm sorry, the same API call toward Elasticsearch. So once you get that filter, visually via GUI, you can actually come back here and look at the JSON query, and you can use the exact same query in your Python script or even curl to get the results in data format versus GUI. So in this case, I'm just showing I'm using a simple curl using the same body that I've copy and pasted in, and I'm getting that same format that I was looking for. So I could actually do more analysis. In this case, I could choose to do my own visual instead of using Kibana. So that is all in great. And now we're getting into the visualization. We're actually doing the visualization on the Kibana, where you just pick a visualization. I pick a pie graph. I choose different sub buckets so that now I have a breakdown of between NetFlow version 9 and NetFlow version 5. And now, it's just showing the vertical bar on the number of entries that I've received on Cisco NetFlows. So now I've saved those visualization, and I'm able to create a dashboard by placing this visualization, these saved visualizations side by side. And what is nice is that once you put them in, you can actually change the time range, and you automatically, as new entries comes in, these are dynamic graphs that are data backed and updated automatically. And also another thing is you could save this visual and you could share it with your colleagues, with your customer, and this is just showing that we could share it, and then you just use for yourself for data dashboard monitoring. All right. So that is the demonstration on the quick workflow. And again, I want to thank you for having me. I really enjoyed this talk, and preparing for the talk. It's always fun to talk to other people about Elasticsearch and what we've done and share our experience. Please feel free to connect with me on Twitter or LinkedIn, whichever format that you choose. And I want to thank you very much. Have a good day.